Here in this exercise, we again elaborate how to find electric field at an observation point due to an array of charges. There could be multiple charges. Here in this case, we have four charges. So let me draw a slightly bigger version of the figure. That's the same diagram there. So let's say this is charge Q1, Q2, Q3, Q4, right? So they're all equally distant from the center, and blue here represents positive and red negative, but that need not be always consistent on that. So that's Q1. Let's begin with charge Q1. That's your source point. When we are talking about charge Q1, the electric field due to charge Q1 depends on the source point, that's that position, and the observation point is at the origin in this exercise. Draw a line between charge Q1 and the observation point and extend it away from charge Q1 because it's a positive charge. So electric field will be this direction. So that's your E1. Let me write the expression for E1, E2, E3, E4 as we proceed. So E1, it's clear that it will be in the direction horizontally away. But let's begin by writing the magnitude. So that's K times Q1 over the distance square, which is L, right? L is the distance between them. So its direction is in the I hat direction. Let me begin by calculating that number right away here. So magnitude of E1 is K times Q1 over the distance between the observation point and the charge Q1 squared, and that's equal to 9.0 into 10 raised to 9. Q1 is, we are doing the magnitude, so this is magnitude. So that's 1.0 into 10 raised to minus 6 divided by the length square, where the length was 40 centimeters, which is 0.40 meters, and you're square it. That's equal to numerator as 9,000 here. That's 9,000 divided by 0.4 square. And to two sig digits, it is 5.6 into 10 raised to 4 Newton per coulomb. So here, this number, let me write this as a number. This will be eraser, will be equal to 5.6 into 10 raised to 4 I hat plus 0 j. That's your direction of electric field, E1. Let's go to E2. So let's charge Q2. The distance is the same, but the charge now is doubled to 2, but it remains positive. So that means as at the observation point, it still will point away from charge 2, but this time it will be double in size because the charge has double, distance has remained the same. So describe that as this is 2 times 6. So that's E2. So that's E1. Actually, yeah, so E2 clearly is 2 times E1 magnitude of E1. So if it is 5.6, that will be 111.2 into 10 raised to 4. So it is good to actually write this, go back and write this as magnitude of E1, because everything it seems like can be expressed in that form. E2, the electric field at the origin, at the observation point, which is the origin, due to the charge 2, is there is no horizontal component for it, so there is no horizontal component. It is pointing downward, so it is minus, and the magnitude is 2 times E1, j direction, the negative j direction. So let's proceed and work with E3. E3 is negative. This time it is 3 times the magnitude of Q1. And we can say, but notice the difference now. This is a negative charge. So the electric field will not be pointing away from it anymore. It will be pointing towards it. So this will be 3 times larger than this, and it is pointing towards the charge. So that's E3. Magnitude wise, it is clear that it will be 3 times the electric field into 1. And that's because it's only the charge has increased in size, the distances as remain the same. That's 3 times E1. So representing that as a vector, we say E3 is equal. It is horizontal to the right, so it is 3 times E1, which where E1 itself is 5.6 into 10 raised to 4, and no vertical component. Finally, we work with E4. Let's see what is the direction and magnitude. So at the observation point, we have Q4 here, and earlier we were working with Q3. Q4 is actually 2 times that of Q1. Uh, so it will be exactly the size of E2. So it seems like E2 and E4 might just cancel out. It is pointing away from charge 4 in the upward direction, and it is twice the size of E1, which was pretty much what happened with E2 also. So let's see how it goes. So E4 is equal to 2 times E1 plus 2 microcoulomb plus 2. So Q2 and Q4 are the same. So this is no horizontal component, so it's 0 I hat, but this time it's pointing upward, so it's plus 2 times E1 J. That's your individual electric fields. The total electric field at the observation point, which is the origin, will be the sum of all these forces. So, or sorry, sum of all these field lines. So E total would be these two cancel out, notice, and here they add up. So it is 4 times E1 times I hat. So that's equal to 4 times E1 was 5.6 into 10 raised to 4 Newton per Coulomb, and it's now in the I hat direction. So E total is, let's put the direction to begin with, I hat 5.6 into 4, that's 56 into 4, that's 240. 24, and that's 22.4 into 10 raised to 4. So that's 2.2 into 10 raised to 5 Newton per coulomb. That's your electric field at the origin as a resultant of all the four charges, and it's clearly going in the upward direction. The horizontal components exactly cancel out. Having known the electric field there, it is easy to find what will be the force exerted on a fifth charge placed there, and that's the next question. Determine the magnitude and direction of the electric force experienced by another positive charge Q5. So force, let's call that force F5, or in this case, there's only one force we are discussing. So force is equal to Q5 times the total electric field at the origin. Q5 is placed at the origin. That's equal to, is a positive charge, so it is 5.0 into 10 raised to minus 6. Direction is I hat, and magnitude of the electric field is 10 raised to 5. The charges, unit of charge cancels, and we have newtons remaining. Direction is horizontal. It is clear that these two add up and these two cancel out, so it's horizontal. And 10 raised to minus 6 and 10 raised to 5, there's a 10 raised to minus 1 remaining. 5 into 2.2, so that's 11. 5 into 2.2, so that's 11, and there is a 10 raised to minus 6, so that's 1.1 and newtons. So the magnitude is 1.1, units is Newton, and the direction is the horizontal direction, that is to the right. So that completes the problem, and let me stop sharing and then stop the record.